factoring, okay? So let's take a look at this. If I have something that looks like this, this is a monomial times a polynomial. What do I do when I have something out in front of parentheses like this? You distribute, exactly. And what do I do? Like, do I add 3x plus x squared? Times, I multiply, right? Okay, so 3x times x squared would give me what? 3x cubed. What about 3x times 4x? 12x squared, good. 3x times negative 6? Negative 18x, perfect. So this is the direction that we've been going, right? We distributed to take a monomial times a polynomial, and we got this. Now what we're going to do is we're going to go backwards. We're going to undo this multiplication. How do you undo multiplication? Division, exactly. But what this is called in this instance is factoring. We're going to factor. Okay. It's sort of like dividing. Yeah. Okay, and we'll see that in just a second. Okay, so we're going to write 8 examples on this paper. 8 examples we'll do together, and then I've got some practice for you. Excuse me? Okay, so I have 63n minus 56n to the 5th. So when I'm factoring, my first step is to find the greatest common factor. I'm recording this so you can watch it later, okay? Just take the Tuesday paper with you, and you can do it tonight. Okay. Yep.
Can you hear what you're saying?
Yeah.
In the video?
Yeah.
So I can also do it right now.
Yeah. You could also hear Dylan yell what he yelled earlier.
Don't say bad words, Dylan. Stop saying cuss words, gosh.
Zane.
No more hungry.
At least it's silent.
I love hungry.
Okay. What's the greatest common factor here? Greatest common factor. So look at the numbers first. What's the math? Math, num 9. What's my greatest common factor between 63 and 56?
I got you. 7.
Good, 7. 7. And then this one, this has 1 n, and this has 5 n. So how many n's can I take? 1. So my greatest common factor is then 7n. This is what we did yesterday. So if you missed yesterday or you were confused about yesterday, we're going over it again. So greatest common factor between these two things is 7n. Now we're going to take it a step further. So what I do is I take 7n and I stick that out in front just like I had up here. And then I set up my parentheses. So now I got to think about 7n times what would give me 63n? 9, exactly. 7n times what would give me 56n to the 5th? N to the what? 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 And what do I put in between these two things? Good. Okay. So once again, I'm starting with this and I'm going back to this format. Okay. So get another example. Negative 42 x cubed minus 12. What's our greatest common factor? What? Yeah, 6. For real. This one has 3 x's How many x's does the 12 have? None. So can I take any x's from both of them? No. So my greatest common factor is just 6. So I stick the 6 out front, and I have parentheses. And 6 times what? Negative 7. Wait. Huh? X cubed. And then 6 times what would give me negative 12? Negative 2, but yes. Okay. And notice how both terms, like all the terms in the parentheses, are negative. What I can also do to just make it a little neater, I guess, is I could take out, instead of just a positive 6, I could take out a negative 6, and then that would make both terms inside the parentheses positive. Does that make sense? 3. Now we've got negative 6a cubed minus 7a squared minus 6a. Got to figure out what is the greatest common factor. What do they all have in common?
And then I already do math one time.
Okay, got to do it twice, huh? Yeah. There's no number because 6, 7, and 6, their greatest common factor is just 1. So I could just put a 1. But then they all have an a that I could take, right? And what else do you notice? They're all negatives. So it can be negative 1a or just negative, or just negative a, right? So I stick my negative a out front, and what do I put in my parentheses?
6 times 6, 7.
Negative a times what would give me negative 6a cubed? 6a squared. Negative a times what would give me 7a squared? Plus 7a, because this is a negative a times a positive 7a, which would give me negative 7a squared. Negative a times what gives me negative 6a? Positive 6. Okay. And these are really nice because you can always check your work. If we redistribute, then I should end up back where I started. So negative a times 6a squared, that's negative 6a squared, or a cubed. Negative a times 7a is negative 7a squared. Negative a times 6 is negative 6a. So I end up where I started again if I redistribute it back out. So that means you can always check your work. Okay. 4. 48n squared minus 18n cubed plus 24n. First step, find our greatest common factor. Do you want me to go over how to find greatest common factor of 3 numbers on your calculator? Okay. So we're looking at 48, 18, and 24. So we got to do math, num, 9, and then do it again. Math, num, 9. In the first set of parentheses, we put the first 2 numbers. So 48, comma, 18, close parentheses, comma, 24. 6. Okay, so that's part of it. What else? What else could I take from all three of those terms? Yeah, an n. So my greatest common factor is 6n. So I stick 6n out in front. 6n times what gives me 48n squared? Six n times what gives me negative 18n cubed? Negative 18 minus 3n squared. And then 6n times what gives you 24n? Positive 4. Cool? Does that make sense, you guys? Okay, number 5. Negative 18x squared y plus 9x. What's my greatest common factor? 9, 9x. Good. 9x. So if I take 9x out in front, what do I put in parentheses? And then what? Is that it? 1 plus 1, right? It's tempting to like, okay, I had 9x and I took 9x out, so it's tempting to just kind of forget about it. But remember, if we redistribute, you need that 1 there as like a placeholder so we don't lose that 9x. Does that make sense? Ah, 6. 36x y to the 5th plus 9. What's my greatest common factor? Yep. So if I take 9 out in front, what do I put in parentheses? Yeah, to the 5th, because I didn't take a y out, so it just stays as it is. And then what? Plus 1. Perfect. Okay, 2 more. 7x to the 7th y cubed minus 6x squared y to the 6th plus x squared y to the 4th. What's my greatest common factor? What do all three of those terms have in common? How many x's? And how many y's? Y cubed. So I could write 1x squared y cubed, or I can just write x squared y cubed and drop that y. I've got x squared y cubed out in front. What's inside parentheses? Because x squared times x to the 5th would give me x to the 7th. And do I have to put a y on this term? If I put a y there, what would happen? Y cubed times y gives us what? Y to the 4th, is that what I want? No, so I just leave the y off. 7x to the 5th, and then x squared y cubed times what would give me this middle term? And what goes in between? Minus. Yeah, good. And then what about my last term? What am I, huh? Plus y, right? I'm not missing any x's. I just need to get one more y there. Okay, last one together, and then we're working on our Tuesday paper. So I've got 50 y squared x cubed plus 70 y squared plus 80 y. What's my greatest common factor? 10 what?
10y.
Good. 10y. So I take 10y out in front. What am I missing from the first term? What else?
Y times 5.
Good. 5yx cubed. What about the second term? And the last term? Yeah, no y, just 8.
Can I get decimals in this?
On the practice paper, there are a couple decimals, but they're only like halves.
Yeah.
Yeah. Okay. So now we are working factory practice. So we're working on this paper. Okay. The first step is like the easy part because they tell you what to factor out. So it says factor 6 from 36n plus 30. So you should write 6 parentheses. What's 36n divided by 6? 6n. And then 30 divided by 6? So plus 5. Okay? So that's what we're doing for the first part. Second part down here, that's what you did yesterday. Find greatest common factor of these two things. And then on the back, there's an error analysis question. So they show someone who factored this and they came up with this answer. This is incorrect. I want you to tell me why. And then the last part is what we just did together. So your first step needs to be find the greatest common factor. And then you put that greatest common factor out in front and then factor it out of the polynomial. So just what we just did. Does that make sense? Any questions? Okay. So you have the rest of class to finish this up.